discussed earlier, a hazard is something biological, allergenic, chemical, or physical in food that could cause a health problem. An important part of hazard assessment is determining the level of risk with each hazard. This is done by checking into the likelihood of a hazard actually occurring, and also by looking at the severity of consequences, or how badly this hazard might affect people's health. To help understand a hazard's probability and the severity of consequences, let's look at the example of raw meat. The probability that raw meat contains harmful bacteria is considered medium. But even so, if handled properly, the raw meat is not likely to hurt someone's health because most meat is cooked properly. So the hazard risk is assessed as low. Let's use a cooking step for a hamburger as another example. The severity of illness associated with an undercooked hamburger is high, as dangerous E. coli may survive, and it is known that low numbers can cause serious illness. The probability that this will happen is low if the hamburger is cooked properly, so the hazard risk is assessed as low.
Assessment helps determine which hazards are of the greatest likelihood and severity to need the controls of a HACCP system. The second HACCP principle is to determine critical control points. Now, this is important because if control is lost, it's likely that human health will be compromised. A critical control point, or CCP, is a control step used to prevent, eliminate, or reduce a hazard to an acceptable level. The third principle of HACCP is to establish the critical limits that must be met at each of the identified critical control points.
Critical limits are what must be met to ensure that a critical control point effectively controls a hazard. Criteria most frequently used for critical limits are time, temperature, water activity, pH, preservatives, microbiological, and sensorial information. In the production of fluid or whole egg product, pasteurization is a critical control point. The most crucial parameters, the critical limits, are the duration and the temperature of pasteurization. For example, the temperature that egg must be pasteurized at and the holding time.
These time-temperature combinations are minimum critical limits that have been established to make sure that harmful microorganisms are destroyed. These critical limits help ensure that food products are safe. Now, the fourth principle is to establish and implement procedures to monitor each critical control point. Monitoring is the process of checking that the critical limits set for each CCP are being met.
Monitoring involves systematically observing, measuring, and recording the most important factors needed for control. Continuous control using automated methods is best. When continuous monitoring isn't possible, regularly scheduled monitoring by trained personnel is needed. Quick, easy methods are best suited for monitoring so a problem can be identified and corrected immediately. Record all monitoring data for future reference. And remember that at times it might be necessary to make adjustments to the CCP monitoring to ensure food stays safe.
The fifth principle, take prompt corrective action whenever the monitoring indicates that limits are not met. If proper corrective action isn't taken, human health might be at risk.
The corrective action to be taken depends on the potential hazard. This might include stopping production, extending the cooking time, increasing processing temperature, increasing acidity, or reworking or discarding product. For our hamburger example, it would require that cooking continue until the critical limit of 71 degrees Celsius is met. For canning, it would mean that the required time, temperature, and/or pressure is met.
The sixth principle is to establish verification procedures. Now, verification procedures reveal whether or not identified food safety activities are actually getting completed. This means checking the checker or asking the question, is it getting done?
One example of a verification procedure is to determine if the process is getting done properly. This can be done by evaluating the records associated with a given CCP. Are the records being filled out properly at the required frequency? Can the person who is doing the documentation be identified by their initials? Were corrective actions, if any, taken effective in controlling the hazard? For example, if the temperature of the hamburger was taken and it was recorded as 66 degrees Celsius, the corrective action should indicate that the hamburger was further cooked and temperature measured again to ensure that it reached the critical limit of 71 degrees Celsius. Other verification activities include interviewing staff on their understanding of the CCP, corrective actions, and record-keeping requirements, and to observe the staff member who is monitoring the CCP to ensure they are doing the monitoring properly. A final verification activity may include product testing for the presence of the hazard of concern.
The seventh principle is to establish documentation and record-keeping procedures. Documentation must be kept on file, including details on how the HACCP team conducted the hazard analysis and determined the critical control points and the critical limits. Records should be kept for activities like CCP monitoring, deviations and corrective actions, and any modifications made to the HACCP system. This is also known as the logbook of changes.
A permanent record is invaluable in showing whether safe, correct processing conditions are being completed, or in showing that any out-of-control processes are properly corrected. Once records and documents have been developed, they need ongoing attention to ensure they are being used properly and that they stay up to date. But the time put in is well worth it. Another important part of HACCP is validation. Validating is making sure that your process is effective in controlling hazards. It means asking yourself, is the process working? For example, does the pasteurizer always reach the temperature of 75 degrees Celsius for 16 seconds, and does this destroy all harmful bacteria every time? We have now reviewed the 7 principles of implementing a HACCP plan. Remember, HACCP requires constant upkeep so the system ensures food safety. This keeps people safe and keeps food products safe, reliable, and more competitive in the marketplace.